company called Chicago Biofuels. It's a very small company. It's myself and one other person, and we operate out of Chicago. We basically collect used vegetable oil, and we provide it to biodiesel producers. I've been involved in biodiesel in one aspect or another for probably close to 7 years. I was an environmental science student and engineer by trade, so I was always just very interested in working on these global problems that we have to solve, all these problems we're up against. So it's through some of this work that I got invited to be a Climate Reality Leadership Corps member, which was basically this program that Al Gore started, and it was an extension of all the work he's been doing for the environment since he's been giving these slideshow presentations for years, for over 20 years. And so I was really excited. I thought, oh, it'd be cool to get to meet Al Gore. I didn't know how big the thing was going to be. It came to Chicago. I sat way in back. You can barely make out Al Gore in front, so it wasn't the type of thing where you can meet him and stuff, which was actually good because it meant that there was a lot of people interested in learning what basically learning about the latest in climate change. And the reason I wanted to speak to you guys about this is so that everybody's on the same page in terms of what's the climate reality and how does this affect our businesses and how can we let our patrons or our customers know that biodiesel is very sustainable and that it's very important for us to keep moving forward in our endeavors. So just to sort of start off the whole thing, this is a picture called Earthrise. It was taken by the Apollo 8 mission. This was actually the first time, it was back in 1968, that humans have seen the Earth in this light. Like, it's easy for us to kind of forget about the whole global picture. We're all in a classroom, we're focused on what we're going to have for lunch or breakfast. But when the Apollo spacecraft came around and saw this image, and then they showed that to everybody on Earth, it really was a wake-up call that, we don't have a lot of leeway in terms of what we can do with this planet. And we are directly involved in making sure that we sustain the planet so that we can live. And it was based on this picture that not too long after that was when Earth Day started. It's when the EPA got formed and became this sort of environmental movement that was spurned by one single image. So what's been going on since then is that through global warming, the Earth has been heating up. So this sort of shows you global warming. This is a model simulation of what's been occurring where we've gone from just average temperatures to above average temperatures. And you can see throughout time, from 1884 till 2011, right now we're at 1990, 2000. You can just see across the globe, pretty much everywhere around the world, temperatures are getting above average. The 12 hottest years on record are right here. They've all occurred. These are the hottest years. We're basically entering an unprecedented time in terms of the Earth heating up. 2012 was the 36th consecutive year where the global temperature was above the 20th century average. And how's this affecting us? Maybe it's not a big deal just to be 2 degrees above average, but in some places it's really starting to become a serious issue. In 2011 in China, they reached a record of 122 degrees Fahrenheit. This is in Iraq, 2 different locations. The temperature got to 127 degrees Fahrenheit. This is hot, I get hot when it's 90, 95. In Chicago, it seems pretty hot. And I was trying to imagine, what is it like to be in an environment where it's 128 degrees? And I couldn't imagine what it was. So I was like, well, I've been in a hot tub before. That's pretty hot. So I go on Wikipedia, what's the average hot tub temperature? It's like 102 to 104. And they don't recommend you stay in a hot tub for more than half an hour or more because it's detrimental to your health because that heat is bad for a person. So just imagine trying to be somewhere in Pakistan, probably no air conditioning, how are you going to cool down? Yeah. So back to the U.S. These are the daily heat records that were tied, were in orange. And then the dark red was records that were broken. There's close to 5,000 records broken just in June to July of 2012, last year. The hottest month ever in the U.S. was last July. You guys probably remember this. There's a thing on the news where, imagine you go to get on a plane somewhere and you get loaded up, or you sit down, you get your seatbelt on, And then all of a sudden they say, sorry, the plane, everybody's got to get off the plane, you got to deplane. And why would that be? It's hard to see this, but the airport in Washington, D.C., the tarmac actually melted, and the wheels from the airplane sank into the pavement, and that plane couldn't take off. So everybody had to get off the plane due to it just being so hot. Australia's been experiencing extreme heat. It's so hot, in fact, that this is their average. This is what they would show people in the news, how hot it's going to be. They had to add some extra colors to the color map. They had to extend the color map just because it was getting to be so hot. And this obviously has an effect on people just trying to cool down. In Alaska, in June of this year, got to 96 degrees Fahrenheit, which is extremely unusual. People are out in bikinis in Alaska. So why is this happening? What's going on? So this is a picture of the Earth's atmosphere. The Earth's atmosphere is very thin compared to the Earth. And some people say it's similar to like a basketball. If you were to put a coat of varnish on a basketball, that's about the thickness of Earth's atmosphere. And that's what protects us from the outer space. It's what provides all of our air that we breathe. The problem is that as solar radiation comes into the Earth, it hits the atmosphere. Some of it bounces off, some of it gets absorbed. In normal operation, without any additional CO2, a lot of the Earth's radiation is allowed to just go back into space. So Earth remains at a constant temperature. But what's occurring now is that an increase in CO2 is allowing more and more heat to get trapped in Earth's atmosphere. And that's what's called the global warming effect. And some people argue that, well, maybe it's because of the way the Earth is heating up, not because of global warming from man-made effects, but because we're getting close. There's natural cycles throughout geological history where you're closer to the sun, further away from the sun, and there's some of that going on. But a lot of it shows that it's directly related to CO2. So if you look at Earth right now, this blue circle sort of represents the CO2. Right now we're about 400 parts per million CO2. Venus is at 96% CO2 in their atmosphere. The rest of it's nitrogen. So they're extremely dense in CO2. And if you look at the temperature averages, for Earth it's 15 degrees Celsius. For Venus it's 457 degrees Celsius. It's hot enough to melt lead on the surface of Venus. It rains sulfuric acid. It's not a very nice place to be. And people will say, well, maybe it's that hot because it's just closer to the sun. But if you look at another planet called Mercury, there's no atmosphere on Mercury, and the average temperature on Mercury is 167 degrees Celsius. So it's not necessarily, it's directly related to CO2 is what that image is trying to portray. And we can kind of chart this. We can look at the history of fossil fuel emissions in our country, in our world. So back in 1850, before the big industrial revolution, before we started burning a lot of fossil fuels, Earth's CO2 was just sort of in balance. And then obviously as we get closer to present day times, CO2 emissions just took off. Where do greenhouse gases come from? They come from a lot of different places. They're naturally occurring. When you have a forest fire, that burning wood releases CO2, goes into the atmosphere, and normally the plants would reabsorb that and take that CO2 back into the ground and into matter. But now because we're pulling out so much more CO2 than we can sequester through natural means, it's accumulating in the atmosphere. So this sort of charts so I spoke about the geological history, the changes in CO2. There's been a period of ice ages where we'll have ice all across the world, and then we've got warmer periods, and all of these follow sort of a cyclical nature. So this chart basically shows you the CO2 in parts per million concentrations over the past almost million years. And then you'll see the temperature equivalent. It very closely follows the CO2. So this is what's been going on for the past 800,000 years. Now we're starting to enter into an unprecedented time where you can see that previously, we never really got above 300 parts per million. Now, you can see way at the top, the 2013, we just passed a marker of 400 parts per million. So you can see way at the top. If we continue on this current trend, without abating any kind of CO2 emissions, what's going to happen is this is going to have to basically go a lot higher. After 40 more years, at the current rate of increase, we're going to be at 600 parts per million. Now look how close these temperatures correlate to the CO2, and just imagine that if you were to extrapolate for the next 40 years, where's the temperature going to be then, if it tracks the CO2 so closely? So this is really a good indication that we have to curb fossil fuel emissions and get closer to zero carbon economy. This chart here is basically a bell curve that shows you the averages of temperatures. And so this is from 1951 to 1980. You can see that in terms of warmer than average or less than average temperatures, we're pretty well balanced. So you might have a record-breaking day in the summer, and then in the winter you'd have another record-breaking cold temperature, and it's sort of everything balanced out. Now what's starting to happen is that the baseline is shifting. And so as it shifts, and as you get further away from the mean to the right, you get into more and more extreme heat events. From 1991 to 2001, you can see it goes even further to the right. And finally to where we are now, where you get a lot more extremely hot days. So when you used to only have maybe 0.1% of the Earth was covered with extreme weather, now it's closer to 10%. Yeah.
That just reminded me, your Australia slide earlier, that 54 Celsius is 129 Fahrenheit. I looked that up afterwards.
Yeah, I was actually going to look that up too, because I don't know
Yeah, it's higher
quick
than
math
those
on
other
that.
temperatures you had shown.
That's ridiculous. So they're definitely hot down there. So all those slides basically accumulate to show you that the Earth is in fact heating up. It's due to CO2. How does that affect the rest of the weather events, and what else is going on with our climate? So one of the big things is, this is the temperature, CO2 concentration. One of the issues is that as the land mass heats up, as the air heats up, the oceans also heat up. So this shows you sort of the 5-year average of, I'm not actually sure what, 5-year average for the surface temperatures of the ocean. As you can see, it's on an upward trajectory, which makes sense. The world is heating up. And so does that really matter if the water temperatures heat up that much? It turns out that it does. So this is, there's a major temperature anomaly where we had elevated temperatures right off the coast, the east coast of the United States in October 29th. And if you remember what happened then, which wasn't that long ago, a huge supercell had started to form. With all this heat that was built up, that energy has to go somewhere. And it's heat and it's moisture and it's pooling up, and it eventually turned into Hurricane Sandy, which is obviously devastating to the East Coast. So I used to spend my times in New Jersey. My grandparents, they had a house on the bay, and I'm sure the house was flooded out pretty bad. These are some before and after pictures of some of those spots that got hit pretty hard. This is a nice little beach community that pretty much got wiped out. It's the New Jersey coastline, Connecticut. It was just a nightmare. Here's the lower Manhattan. People staying in line for fuel. This is an image
What
from
would happen to Manhattan?
Inconvenient Truth in 2006. Al Gore predicted what would occur if we had a huge storm.
They can measure this precisely, just as the scientists could predict precisely how much water would breach the levees in New Orleans. The area where the World Trade Center Memorial is to be located would be underwater.
big and powerful storm. Millions of people are going to be affected all across the eastern seaboard. I think everybody is taking the appropriate preparations. Our thoughts and prayers go out to all the people who are potentially affected.
This extreme storm is related to the warmer ocean temperatures. Tropical storms get their energy from the oceans. Warmer oceans give it more energy.
An explosion at a Consolidated Edison power plant.
More than 1 million people in 11 states are already without power.
Breaking news now from the borough of Queens, New York, where a fire there has destroyed at least 50 homes.
The Battery Tunnel in Lower Manhattan, this gets you out of the city. The tunnel is totally flooded.
And now this water is rushing over the edge of Lower Manhattan.
This was a devastating storm, maybe the worst that we have ever experienced. Many people have lost their homes. People have lost their lives.
The Hudson River, downtown Manhattan, was literally pouring into the ground zero site. All the infrastructure we have in this city is below ground. We don't have any built-in pumping capacity in the tunnel system. The electrical equipment in many cases is in the tunnel system, and now you have a serious problem. But I would expect a situation like this to recur, and I think we need a systemic solution long term. As New Yorkers, we've gone through dark times before, and we know struggles and we know crisis. And we come back, and we come back even stronger. We work together, we work as a team. And the challenge here for us is not just to build back, but to build back better than before. Climate change is a reality. Extreme weather is a reality.
So obviously a lot of devastation, a lot of cost. Katrina was the largest hurricane that hit the U.S. in terms of devastation and total losses, and then Sandy was right there next to it. So that kind of covers like the flooding issues, the water that we're going to have, the additional water created by additional moisture in the sky. This was a slide that just showed the way that moisture moves around the atmosphere. So the real issue is that warmer air can hold a lot more water vapor than just regular air that was at normal temperatures. So with each additional 1 degree Celsius of temperature, the atmosphere's capacity to hold water vapor increases by 7%. So we've already increased maybe 2% or 2 degrees Celsius on average, maybe in some parts of the globe. So that's what's causing these supercells to occur. There's already 4% more water vapor over the oceans than there was only 30 years ago. While 4% doesn't seem like a lot, you imagine the size of the ocean and how much water that is. That's an enormous amount of water. So this hydrological cycle is actually getting sped up because we're evaporating a lot faster because the Earth is warmer. The precipitation is occurring in a lot greater frequency and, well, I shouldn't say greater frequency, but definitely more ferocity, more volume of water is coming down. which returns to the sea and could flood other areas.
One of the changes we've seen is that the average humidity of our planet has increased by 4%. Warmer air holds more water vapor. And so on average, our atmosphere is 4% more humid than it used to be 30 or 40 years ago. So when storms come through, there's more water for them to pick up and dump.
This chart sort of shows the average global temperature, and then basically shows how that directly correlates to heavy precipitation days across the globe. And there's just some enormous storms that are forming out there. So we saw, we have a lot of we probably know a lot of people that were affected by storms in the United States, but huge floods and storms are occurring all across the world. Here's some pictures from Pakistan. Also remember, Pakistan had the 127-degree weather, so they're really getting hit pretty hard in terms of climate change. Here's a picture from the Philippines. This is an emergency room, so it's kind of scary to think that when everything's going bad, well, maybe at least the authorities will take care of us, or I can get to the hospital and be taken care of. All these people came to the hospital, and the hospital's flooded, and the hospital's having problems as well. So in these extreme times is really, where else can you really turn to? A dramatic rescue from a flooded area. Millions of people are becoming homeless and are basically turning into climate refugees because their houses are being flooded or underwater. Germany got hit pretty hard. I didn't actually even hear about this in the news. I don't know if anybody else did. Some images from Canada. So the problem is by dumping all that moisture out of the water, or out of the atmosphere, and then also having that heat, it allows the earth to heat up a lot quicker. And so it sort of forms this cycle where we're going to go from extreme drought to extreme floods and back and forth. So the same heat temperature, the rising temperature that causes the moisture to evaporate from the ocean, is more effective on land. And I think it's got to do with the ocean. The water has a higher heat capacity, it holds temperature more, but land can dry out almost instantly. And so that's why we're going to start, we've already experienced and we'll probably continue to experience extreme drought conditions. This is from Indiana. Last year was a really bad year across the world for drought. This is the driest it's ever been in 70 years in Spain. You can see that the water levels used to be a lot higher, close to that tree line there. South and North Korea, they've suffered through the worst drought that they've had in over 100 years. There's some farmers that were coming to get some water where they used to go, and now they have to go even further to just bring back buckets. These are the drought conditions from last year. This probably affected a lot of people. I know in Illinois it was extremely bad for the crops. You see the Midwest was hit pretty hard. Over 32 states were declared disaster areas in over 1,400 counties. This just shows you across the world what was going on. And this quote says, climate model projections suggest that what we consider today to be an episode of severe drought might even be classified as a period of abnormal wetness by the end of the century. So that means that what happened last year could be considered an area of wetness, which is, it's just difficult to think about. And that a coming mega drought, a prolonged multi-decade period of significantly below average precipitation, is possible and likely in the American West. But we can solve this. I mean, there's technology at hand that can, really help ward some of these things off before it's too late. So this is a simulation. These are drought conditions in the most recent history. And then they've done progressions to show what it might look like, in 20 years from now. You can see that the closer you get to purple and white, the drier it is. This is 2060, 2069. And so you can see, especially in terms of how does this relate to us in terms of biofuels? Well, where are we going to grow our biofuel crops if we have worldwide droughts? It's something that we really have to plan for. And so what inevitably happens once you have dried out areas, you get a spark, you get somebody throws a cigarette out the window, or you get some lightning. Next thing you know, you've got uncontrollable wildfires. So Australia was getting hit pretty hard. You could see from space the devastation and the smoke that was occurring in Australia. Here's a guy helping out a koala bear. And it just makes sense that the hotter the year, the hotter the temperature is, the more fires you have, because it's drier. And that's exactly what this chart shows. It's in Colorado from last year.
Can I say something about that slide?
Yeah, go ahead.
So this fire, the Waldo Canyon fire, which until this year was the most devastating wildfire in Colorado, just last week had 4 or 5 days in a row of significant flash flooding that ended in fatalities. So we went from the type of year where we had no snow and severe wildfire to extreme flash flooding, and just in one little microcosm in this community. And then the following year, and I saw the next slide,
Yeah.
but this was this year.
Yeah, I think it seems like Colorado's really feeling the effects of climate change a lot faster than maybe some other portions of the country.
Can I say something about that too?
Yeah.
On my flight over here from California, I've never seen so many fires burning on the way over. I was watching out the window the whole way, and there was smoke coming from places in California, Nevada, I assume Utah, and possibly Colorado. But there were a lot of big fire events.
Yeah, it's crazy. So Oklahoma. Here's another photo taken from the International Space Station. The smoke from this fire reached European airspace and caused elevated particulate levels. And this was the fire in Arizona where we lost 19 firefighters. Other portions of the world that are being affected, the poles. So this is, obviously as things heat up, the ice is not going to be able to stick around as long. This is what the Arctic sea ice looked like in 1984. And this is basically what it looked like in September of last year. Here's a glacier in Peru in 1978.
I heard the Greenland political leader wants more pollution because it opens up shipping routes to Greenland. So get rid of all that ice. Now Greenland has more seaports.
Wow.
And oil exploration.
That's something big too. It's terrible.
I don't know what happened here.
Thankfully, other parts of Scandinavia are thinking that way.
And thankfully, most of his constituents will definitely go be gone.
Yeah.
Here's the glacier in Alaska. This was in 1880. And this is what it looks like today. So obviously there's a lot of things going on. It affects everybody in one way or the other. I can't really touch on everything because the slideshow presentation was actually like 300 some slides long, and so I don't want to go through all of that. But I did want to start focusing on the food supply, which is sort of by relation relates to biofuels. And so obviously this is from a farmer in Illinois that was likely growing corn for ethanol or cattle feed. He said it's like farming in hell. Like, how can you farm when you have no water? Alabama, extremely dry. Kentucky, these guys are trying to plant some soybeans, not really having much luck. In terms of a global commodity, British wheat crops were devastated in 2013 because they had a wet autumn and cold spring, which I guess is not good for growing wheat. So normally, instead of them exporting wheat, they all of a sudden had to import the same amount. But that wheat had to come from somewhere else. And so as these climate events are occurring around the world, it's really going to offset a lot of, or disrupt a lot of previous exchanges of food and commodities. Not to mention that as it gets warmer, certain crops just don't grow as well. So corn yields are expected to decline as temperatures go up, average temperatures. By the end of the century, U.S. corn yields could fall by 1/3 just from heat stress alone. The huge heat wave in Europe caused a number of problems. Corn production was decreased, fruit harvests were down, hay and grain yields dropped, and wine production was the lowest in 10 years. And 70,000 people died. It was a terrible heat wave. This is really becoming a big issue with insurance companies. They don't really know how to insure for these huge losses that from floods, from farms that are failing. So that's becoming another issue. Water use, which is obviously very important to us in the biofuels industry for agriculture and industry. 70% of the global water use is attributed to agricultural purposes. Saudi Arabia tried an experiment where they wanted to start growing their own wheat. And so they started extracting groundwater. Obviously, they don't get a lot of rain over there, so they had to pump from groundwater supply. And they took an area that was in 1987 was barren and just planted as much as they could. And they did that until they basically ran out of water, and they had to quit the whole program. In southwest Kansas, where we have the Olagala Aquifer, which is the largest aquifer in the North American continent, I believe, that's being pumped down at extremely fast rates, and it says here at the current rate of depletion, 35% of the high plains will be unable to support irrigation within the next 30 years. And we do get a lot of food from that portion of the country. So then what happens when you have plantations or plants that can't grow due to climate change? desertification starts to happen, where sand will come in and then you just won't be able to grow there after a while. Luckily, camels are able to evolve and they can drink out of bottles of water. So this is also another issue I've never really thought about until I talked to a biofuels researcher from India. They're heavily looking at research at salt-tolerant biofuels crops that produce oil seeds, which never really crossed my mind. We don't really think about that here. But the problem with a lot of floods, overland sea floods that comes in, when that sea goes back, it leaves the salt, leaves the ground very salty. Also, as we're pumping fresh water out of the ground, as that water becomes depleted, you have to dig deeper, and a lot of times the deeper you go, the more salty the water is for irrigation. And so there's a lot of work being done right now to look at what are we going to do with this? How are we going to be able to utilize the salt water, because we're going to run out of fresh water. India's got problems. They lost 6.7 million acres of land due to salinization of the soil. China's aquifers are going down quite a bit. So, you know, it becomes clear, 5 minutes? Okay, that we have to do something. I'm going to skip this real quick. There's a lot of climate change deniers out there. Mostly they're from the petroleum and gas sector, but pretty much every national academy in the world for science has agreed that climate change is real, and it's something that needs to be basically addressed immediately. So, after all that bad news, maybe some good news would be nice. So let's look at what's going on. Solar production is taking off exponentially, wind production as well. Biofuels are doing very well. Every year we're producing more biofuels in this country and this world than we have the previous year. In 2010, for the first time, renewable energy investments have exceeded fossil fuel investments, which is a great step forward. There's a lot of countries that have carbon policies that are being put in place to put a cap on carbon or to put some sort of a tax on carbon. China's got an aggressive carbon program that they're piloting right now. These are the new proposed coal plants up till 2008, and then due to just lack of demand for coal power, these are the ones that have been canceled, which is great news. Several of you probably live in states that have renewable energy portfolios. For our industry, transportation takes up 28% of the greenhouse gases emitted from the U.S., so we have a direct role that we can play to help reduce those emissions. And there needs to be an accurate need for science. So like Don was talking about last night, really, in order to influence policymakers, we need to make sure that we're making informed decisions based on science and not based on biases or based on political agendas. And so that's true to talk to the politicians, and it's also true when you're talking to your constituents about, or your patrons for biofuels and why it's important for them to be involved. Indirect land use is a pretty complex area that I'm not going to address at all right now. But just some of the things to think about in the biodiesel life cycle calculations is, you all might be involved in biodiesel in different areas, but definitely some of the variables are the fertilizer used for farming, the energy supply from the grid, fuel type for tractors and transportation, farming methods, and co-product utilization. So probably anywhere within your business, you may be able to touch on some of these topics and become more efficient. So Piedmont and a lot of other people have done studies. They show that biofuels from waste vegetable oil can have up to 96% CO2 reduction compared to petroleum. So it's definitely it's the lowest carbon fuel available at hand right now. So really, I think we're in a good position to keep forging forward. Target that we have to try to hit is huge. Not only do we have to stop going at an upward trajectory, we need to level off, flatten, and then come back down. So the task is huge. But what other choice do we have really? So, making baseline energy measurements through your own company and then improving upon them is one way to sort of judge how far you're coming with reductions. Simple things like insulating heating tanks is something that can have a profound impact over time. Try to source your process energy from renewables. Oil collectors can use routing software, which would maybe make them a little more efficient when they're on the road to save time and save fuel, and just use as much biodiesel as to help the environment and also to let everybody know that what we're doing is the right thing. So some of the things we're trying out in Chicago, we're putting a lot of front-end filtration in some specially designed dumpsters that we have, basically to keep a lot of the materials out, thinking that if we don't have to process that later on, we're better off in terms of energy. We're doing some small-scale research in alternative feedstock types. So we planted some biofuels crops, essentially sunflowers, which have a pretty high oil yield, double that of soybeans, and also has the benefit of extracting lead from soil. And so in Chicago, there's 70,000 vacant properties. A lot of them are contaminated with lead. So we work closely with a lot of urban agricultural people to work on getting those vacant lots to be useful in either the biofuels aspect for education or for growing food. Outreach and education is something that everybody can do. We all are experts in the field, and a lot of people still have never heard of biodiesel, or that you can make fuel from vegetable oil. So we're all stewards in that regard to be able to go out there and let other people know that there's other alternatives to fossil fuels. Other things is win the conversation. What does that mean? Basically, when you're talking with a climate denier or somebody that doesn't really understand what the climate science is, to let them know that, yeah, this is real, it's not something that goes away, and we have to do something about it immediately. This is from the Climate Reality Project. If you're interested, you can go to the website. They have a lot of information about climate change, things you can do personally, things you can do to join different events around town. Everybody in here is a consumer in one way or the other, so make decisions that will somehow help reduce carbon is a very helpful thing. And don't give up. Changing laws is even more important than changing light bulbs. It's more important, but I wouldn't think it's that easy. So it takes a lot of persistence and talking to your leaders and talking to people that can make the decisions and letting them know that you're the voting public and this is what we want to have happen is very important. So just to kind of go back to what we started with, we've only got one planet. There's no planet B. We can't really screw this up, and I think we're at a critical time here where it's we have to make the right decisions, or it's going to cost us. It already has cost us a lot, and we have to slow down the effects of global warming. So this is a picture that was taken in 2010. This was from 4 billion miles away from Earth. So the Voyager 1 satellite or spacecraft has basically traveled for the last 35 years away from Earth to search out what's going on beyond our area. And they're at the edge of the solar system, and they turned the thing around and took a picture of Earth. And that little teeny tiny blue dot, that's Earth right there. And as you can see, there's really nothing else around it. So we just got to take care of what we got. Thank you.